Good afternoon, everybody. This is a live emergency severe weather briefing. As the threat of tornadoes and the tornado probabilities have been increased across northern Mississippi into central Tennessee, most of that threat's going to happen after sunset, but we've already got some severe weather here in western Tennessee, just to the east of Memphis, including the Germantown to Collierville areas. But this is an absolute mess in terms of organization. As you can see, anything that maybe this back one is close to being a transient supercell structure, but you can see a lot of convection out in front of it that is impeding its inflow. These are likely elevated storms right now, but they did initiate in eastern Arkansas right about where we thought that was going to happen. But that tornado threat does appear to be a little bit delayed. You can see that this is likely a supercell here closing in on Germantown. You're probably going to have some enhanced damaging winds and some increasing hail sizes there. That does appear to be a deviant motion, moving almost east-northeast there. Relative to the other convective elements, it definitely is moving a little bit further right, which tells me that it's a supercell storm closing in on the Germantown area. Probably an elevated supercell storm, considering that convection to its south and southeast don't appear to be impeding inflow too much. But this thing has a deep mesocyclone, it looks like here. It does have the resemblance of an elevated mesocyclone, but these things can drill down through any shallow stable layer out ahead of it. And definitely is a mesocyclone that appears to be increasing here. It's over Capelville to the southwest. Well, it looks like the new mesocyclone is definitely consolidating there just to the southwest of Germantown. So there's going to be some elevated hail sizes within that. Mesocyclones increase the updraft inside of a storm, the updraft speed, and its ability to suspend larger hailstones up in the atmosphere for a longer time. So this is definitely a pretty dangerous storm here in the Germantown, Tennessee area. South wind, you could get hammered, especially by these RFD winds. They're definitely strong down near the Capelville area. Main mesocyclone's kind of in this area, just a giant vacuum cleaner up above it. Any eddy that can propagate beneath that vacuum cleaner, that low-level mesocyclone, has a candidate to get coupled with the updraft and become a supercell tornado if that mesocyclone extends low enough into the troposphere. And you need to have favorable shear parameters. You also want to have relatively unimpeded inflow into these storms. And it looks like we've got some convective elements way out ahead of this thing to the south of it that definitely would impede inflow into this storm. But there is a 5% zone for tornadoes that has been issued for northern Mississippi into central Tennessee, including western Tennessee out ahead of this thing. More of a nocturnal threat, but this is just the beginning, this cluster of severe storms. With this supercell just to the southwest of Germantown, we can definitely see the enhanced updraft speeds from a mesocyclone by these echo tops, especially with the radar a little further away. Be able to see that better. But here are those big-time echo tops above that mesocyclone going high up into the atmosphere, probably about in excess of 40,000 feet, 45,000 feet up there. So this is definitely a deep mesocyclone, probably some big hail. So this is how you can tell that a rotating updraft has a stronger updraft than a non-rotating one. The echo tops are higher. That storm is penetrating higher up into the troposphere, probably even some overshooting tops, maybe even extending into the stratosphere a little bit. And even though the tropopause is lower overall on average in winter, this thing is still extending higher than all the other storms. And that's how you can tell it's a rotating updraft. And these other ones are probably non-rotating updrafts, low convection out here. So not a ton of impeded inflow. Most of the convection in the inflow zone here is pretty low topped so far. So it's possible that this severe storm, I wouldn't be surprised if this thing pumps out some hail even bigger than 1 inch in diameter, maybe a little bit larger than that. And it's moving northeast at 55. The fact that it's moving so rapidly like that probably indicates that it is just a little bit elevated above a very shallow stable layer, but we'll break down the environments that these are moving into next. This is still from that distant radar down in Columbus, scanning a little higher up in the storm. But you can definitely see the deviant motion with this back supercell relative to the other ones. You can also see that this lead cell out here is starting to intensify. You're scanning relatively high up in the storm, so you're seeing the hail and other larger hydrometeors, other large raindrops suspended high up in that updraft. Definitely a sign of a stronger updraft where you can see some of those bigger hailstones suspended, higher reflectivities up higher up in the updraft. So I think eventually this back supercell is going to be choked off, but who knows? It's definitely the most mature looking storm right now. You can see a bit of a hook echo here on the south side. RFDs kind of like this. It definitely does have a wet RFD in there, but an enhanced area of strong westerly winds there within that RFD. This right here is that hail core about to move into the Germantown area. Next, you're probably already starting to get those decent hail sizes. You got the forward flank boundary right here. This is all the forward flank downdraft. The rear flank downdraft kind of falls behind the mesocyclone and then wraps down to the south of it like this. But that's a mature supercell storm, and that's why there's severe thunderstorm warnings that have been issued for that. But this one's probably going to be the next one to mature to the southwest of LaGrange, right over the Mississippi-Tennessee border. Keep a close eye on this storm down the line to see if it matures a bit. But the fact that this cluster of storms in general is moving so rapidly at 55 knots tells me that it's likely an area of elevated severe storms, but a sign that a jet streak is advancing out over this area. And we really need to watch this zone a little bit further south for the development of surface-based storms, and especially as it heads over toward that convergent zone, and that energy overspreads the area across northeastern Mississippi into central Tennessee, where there has been a little bit of heating today. But let's look up that environment really quick using the RAP analysis here. No mesoscale discussions yet. I also saw there was a severe thunderstorm warning down in the Phoenix area. Some strong damaging winds out there. All right, pulling up the internet. Hang with me, please. I'm going to show you the new 5% area, hot off the press. There's that 5% area from the Storm Prediction Center, and that's a nocturnal threat overnight tonight, northeastern Mississippi, northwestern Alabama, into south central Tennessee. And there's a new Furuno radar unit on the Radar Omega app, which is in Lawrenceburg, Tennessee, in the radar hole down there, south central Tennessee. And we're actually going to visit that radar site tomorrow for Radar Omega, but it's going to be a very useful tool tonight when we're breaking down that severe weather. Lawrenceburg is right in the 5% area there, south central Tennessee, definitely in that radar hole. So definitely check out the Radar Omega app, and you'll be able to see any storms that will move into that radar hole in greater detail. Now let's take a look at the environment. This is an awesome tool for breaking down the environment that storms are moving into. Just love the mesoscale analysis. Thank you, folks at the Storm Prediction Center, for making this incredible tool available to us. So there you can see the instability axis ripping up the Mississippi River Valley there. Surface-based instability. And that area, a cluster of severe storms in that supercell is right on the nose of that instability. So it really should be pretty close to the northern nose of that surface-based instability axis. Capes 1,000 to 1,500 surface-based capes there. A little bit of convective inhibition in northeastern Mississippi, but that's likely going to erode as we go through the afternoon. Let's look at the forecast here for that instability axis with time. 2 hours. And it does try to expand a bit. It extends east at least with that convective line, but notice how that convective inhibition builds in up to 50 joules per kilogram negative buoyancy there in the low levels is definitely going to be a negative factor for tornado potential. That's why the RAP seems to have more robust convection in central Tennessee, central and southern Tennessee, where the low-level wind shear is not as conducive for tornadoes. Low-level wind shear up there in western Tennessee is a bit greater. But also notice how the surface winds veer with time. They go westerly overnight tonight. That's also not a very good configuration there, although you do have a lot of speed shear with that. And it does look like there's going to be a reinvigoration in those storms at about 28Z, so 4Z, just before midnight, maybe about 10 p.m. out there. Looks like a reinvigoration of that convection into central Tennessee with that nose of instability extending up there. And some isolated convection down through northwestern Alabama late. That's about 4Z, so it's probably about 9 p.m., 8, 9, toward midnight as well, there into central Tennessee. Let's look at and see what the shear does. You can see decent low-level effective helicities here out ahead of this of 300 to 400 meters squared per second squared ahead of this cluster of storms. More than sufficient for a tornado threat. But look at that shear eject rapidly to the east by 4 hours. So definitely that veering of the surface winds has an impact on the storm relative helicity, causing that wind shear to eject east of the convective line. But then it looks like closer to 9 to 10 p.m. there in central Tennessee. It's almost like the convective line catches back up with the shear. And then it starts to run into that 300 or 400, 500, even 0 to 1 kilometer storm relative helicities, extending down into northwestern Alabama. So there, it does appear that that wind shear kind of keeps pace with those storms. That's probably related to a decoupling of the boundary layer, acceleration of that low-level jet. Most of this wind shear is being contributed by speed shear, but that's why there's a 5% tornado threat. You can definitely see big-time instability there happening. And the RAP did a great job, too, on picking up on convective initiation there in far eastern Arkansas, crossing the Mississippi River toward the Memphis area. Now we're going to take a look at the trusty HRRR, see what those photographs look like. And let's see how well it did with the initialization. Time right now is, what is that, about 22Z? So that's about right. So look at how accurate the HRRR is here. Let me see if I can move this. There it is. So the HRRR is incredibly accurate, the 18Z HRRR, with initiating these storms, even hinting at some supercell structures there in southwestern Tennessee. This is the same storms that we were tracking in our morning briefing here from east central Arkansas, moving into southwestern Tennessee. Thought the tornado threat was going to be more earlier, and then the convective inhibition would build in and minimize that tornado threat. But the Storm Prediction Center seems to think that that tornado threat will increase as we go through the overnight hours. And definitely supported by the short fuse models, the RAP especially. Now we're breaking down the HRRR here. This is at 0Z, so this is 6 p.m. Central Standard Time. Coming up here in about an hour and a half, showing the evolution of these storms. Further convective development, too, down into northern Mississippi. These are the ones that we definitely need to watch as well. They'll move across northeastern Mississippi. These are the storms that we're probably watching now over southwestern Mississippi. In an hour and a half, they're going to be cruising off to the north. And then look at this, the HRRR by 1Z, about 7 p.m. Central Standard Time, just lights up surface-based storms down into northern Mississippi, even all the way down to the Vicksburg area, south of there even, down toward Natchez. A couple of renegades developing in northwestern Alabama as well. So let's look at a forecast sounding for that time, about 7 p.m. This is when my class is going to be getting started. And the photographs look pretty decent out here, just ahead of that convection. There's the photograph with at about 7 p.m., just ahead of those storms. And you can see a lot of speed shear. The surface wind, south-southwest, 1 kilometer wind, south-southwest. But a lot of speed shear with that 1 kilometer wind increasing to near 50 knots, surface wind near 10 knots. So you got about 30 knots of speed shear with this photograph. And those 3, 4, and 5 kilometer winds are sufficiently veered to bring a storm motion east-northeast here at 50 knots for a surface-based storm. The storms right now in western Tennessee are moving at 55 knots, suggesting that they might be just a little bit elevated. But that's not a bad photograph there. That's definitely one that can generate a tornado threat. You do have a little bit of a negative contribution to the storm relative helicity between 1 and 3 kilometers, but that's irrelevant when you have a big shear vector like this and you have strong enough 4, 5, and 6 kilometer winds to evacuate the rain and the hail from the updraft. So even though you do have some relatively shallow critical angles, Further east across Dixie Alley, it is pretty normal to get a majority of that wind shear being contributed by speed shear instead of directional shear. The opposite's true in the high plains, where you get a majority of the wind shear contributed by directional shear, shifting from those easterlies through the lowest couple of kilometers, whipping around to southwesterly. Totally different type of a hodograph, and it definitely populates this upper left quadrant quite a bit more with those wind plots as well to the northwest there. But this is telling me that there definitely is tornado potential with these. Let's see how it looks further south. See how the photographs change with time. And they do get a little bit more veered. You can see that the 1 kilometer wind is a little bit more southwesterly here, but not much of a change in the hodograph even further south into Mississippi. Let's see down here, down near Jackson. Jackson, even not a bad hodograph. You can see that the low-level jet is just a little bit weaker, critical angle a little bit higher. So, man, even down to Jackson, you could get a tornado threat late tonight. It does look like there's going to be convection. Temperature about 70, dew points into the upper 60s. So even Jackson could get a tornado threat tonight. Lawrenceburg, south central Tennessee, also there, could get a tornado threat. Looking at the low-level jet, quite veered. So a lot of contribution to this wind shear is from speed shear. The main surface low is way back here. Low-level jet well displaced from that system. The system's definitely on a weakening trend, as is the upper-level system that's shearing out. But still, you can squeeze out an environment of favorable shear here, because as the system ejects to the northwest, at least it means that the upper-level winds are a little bit more veered, and sometimes you can realize some better critical angles. But this is what happens closer to 9 p.m. You can see an acceleration of that low-level jet, even above 50 knots, as that increases, and the convective line almost catches up to the shear. It's almost like the low-level jet stops advancing to the east because of the Appalachians, because of the topography, allowing that convective line to catch back up to the western gradient of that low-level jet. And that's what happens at about 9 or 10 p.m. into central Tennessee. And I think that could cause an increase in the tornado threat there. 0 to 1 kilometer EHI, Energy Helicity Index, definitely just shows you where the surface-based cape is, but it doesn't really show you that this composite index is dominated by storm relative helicity. Stronger storm relative helicity in central Tennessee into northern Alabama here by 4Z. Kind of spotty a little bit, but there still definitely is a tornado threat with that convective line as it moves off to the east. I almost underestimated the tornado threat this morning, thinking there's going to be too much stable air and this low-level jet propagated too far to the east. And then those storms eventually start running into the southern Appalachians here. Still pretty intense by 6Z. So this is about 11 p.m. Central Standard Time when these storms are still closing in on the southern Appalachians. I need to decide whether after my class tonight, if I'm going to blast west in position for these storms, since we are looking at the radar site tomorrow at Lawrenceburg, or do I just want to wake up at like 4 in the morning and punch into this deal? That was fast. Then it dies out, but you still have some decent convection here just before sunrise, about 4 or 5 in the morning out here, down into northern Georgia. Atlanta, probably going to get some thunder out there. And then temperatures really warm up on Tuesday out here. Temperatures in the 70s, different than some other systems. There's not a big Arctic cold front. The upper system shearing out, lifting toward the Great Lakes, just kind of sending out this little plume of moisture, a little convective line that dies when it hits the Appalachians. So the good news is that it's going to be a beautiful warm day on Tuesday. Let's now look at the snowstorm that's dominating Omaha area. 2 to 3 inch per hour snowfall rates happened, especially just to the south of Omaha. But it looked like that northern edge of the heaviest snow band stopped just shy of Omaha. So this is some additional snowfall. Let's look at snow depth. That's a better way. Depth change. So the HRRR is still showing Omaha being the winner there with a double-digit snowfall. Lincoln has a little bit higher as they were in that heavier band that pivoted just to the south. It does look like that heavier snow band is starting to pivot northward toward Omaha, and that's bringing with it some greater upper level support, greater lift at 500 millibars. But really what I want to show you guys here is a textbook snow sounding. This is at 20Z. Let's see when the heaviest snow happened. Right in that band, I would say. Move this a little. So here you can see a textbook heavy snow sounding, and we broke this down in my last class on winter weather. But notice how there's an abundance of vertical motion in the mid-levels of the atmosphere, between about 500 and 600 millibars there. That's where those big dendrites, those big snowflakes form in the mid-levels of the atmosphere. So it needs to be moist, needs to have lift up there, and even some steep lapse rates would help out. But this is just a textbook snow sounding, showing an abundance of moisture through the mid-levels of the atmosphere, a lot of lift as well. And look at how the profile stays completely below freezing as well. Some of those higher radar returns to the south of Omaha, I was wondering if that could have been some bright banding as that warm nose inched up to the zero line. But I couldn't find any evidence of that using some of the other radar products. I do think there's going to be some bigger totals just to the south of Omaha as well. But let's look at do a radar update. Radar update now on the snowfall and the severe weather. Storms still appear elevated up here in southwestern Tennessee. Still watching those lead echoes to see if they become surface based, but these look like they're elevated, just cruising at 55 miles an hour. Not a lot of deviant motion, and as expected, this rear supercell seems to have had its inflow choked off from these convective elements just to the south of it. We'll have to watch some of these lead elements to see if they develop a surface-based threat. This thing's probably dumping its hail now as that mesocyclone's weakening, likely dumping its hail to the northeast of Germantown, north of Piperton, south of Oakland there. But now let's shimmy on over to the tornado, or the snowstorm that's happening in Omaha. So this is that heavy deformations band that has been persistent here from Lincoln to just south of Omaha through Red Oak, Iowa, and this surface low is beginning to weaken. So this is the peak of the snowstorm right here across eastern Nebraska into southwestern Iowa, back into northern Kansas. And I've been watching this. It does look like it's pivoting back to the north. So if snow lovers in Omaha, you're going to love this update, this deformation zone. This is where the max lift is at 500 millibars. So you're really generating those giant flakes the size of dinner plates out there from Lincoln just to the south of Omaha. And this band is heading north toward Omaha and will likely continue to pivot over the Omaha area, dumping quite a bit of snowfall through the evening. So this snowstorm is just getting started. A lot of times these will overproduce on the backside when you get kind of a bigger deformation zone, and that deformation zone extends all the way back toward the Hastings area with still some decent banding happening in there. So snowfall is going to last quite a long time, and I think there's probably going to be over a foot final tally here in Omaha, maybe 12 to 14 inches. Bellevue probably even more. Somewhere between Bellevue and Nebraska City likely will also get even more snowfall, somewhere in this zone. Definitely fun to break down these snowfall events and the nocturnal severe weather event. We're just going to have to see how that plays out overnight tonight at the same time as my varsity tutors class at 7 p.m. And then right after that, I'm going to monitor the evolution of convection, and if it looks like I need to head to central Tennessee, that's what's going to happen. So thank you, everybody, for joining me for this weather report. I really appreciate everybody. Please consider checking out the Facebook supporter platform. Starting this week, I'm going to be promoting a new educational platform for storm chasing. Every week, I'm going to deliver an educational class to Facebook supporters only. And definitely check us out. A lot of that goes to support our Team Dominator Science, to make live streaming possible, live weather briefings just like this. Thank you, everybody, and never stop chasing.